Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into
the
it.
drive shaft, often referred to as a half axle, is not part of the cardanic gear. It is part of the design of the car, transmission, and is an important part of it. Today we will consider what tasks the SP performs, what kind of semi-axles there are, how they function. We will also consider why these transmission units fail, and how to increase their resource. Purpose of the semi-axis. What is the semi-axle of the car is known to all drivers. The main function of this part is to transmit torque to the driving wheels, support the ability to turn the wheels at speed, as well as ensuring the smooth movement of the vehicle in the presence of minor vibrations. As a rule, the drive shaft is installed on the uncontrolled wheels on vehicles with dependent suspension. In the case of independent suspension, this function is taken over by the cardan transmission, and on the uncontrolled, for passenger cars it is the rear wheels is installed joint mechanism of unequal angular velocities, and on the controlled front with this task is coped with a joint of equal RS. In general words, you can describe what the semi-axes are designed for, as the ability to take on themselves the action of various forces formed as a result of the movement of the car. Note that in absolute values, these are very serious loads, so the design of semi-axles and the material of their manufacture are subject to high requirements. The presence of two joints in the drive shaft, located at both ends of the part, allows you to significantly reduce the vibrations transmitted to the steering column, preventing the movement of the car jerks. Device, principle of functioning of the semi-axle. The design of the semi-axle is arranged in such a way that the maximum torque transfer coefficient is provided regardless of the current position of the wheels. Let's consider what the semi-axle consists of: the outer ball joint, the joint that provides the interface between the wheel hub and the axle; inner ball joint, which transmits torque from the differential, the axle itself. Physically, the axle shaft is a piece of solid pipe, to the ends of which the adapters for mounting the angular velocity joints are welded. To prevent these parts from twisting, they are splined. The shaft is additionally fixed at the junction with the adapter with a locking ring, preventing the possibility of disconnection of the axle from the ball joint. This is the double joint design used on most front-wheel drive cars, with both joints performing slightly different tasks. The inner ones dampen vibrations during vertical movements of the wheels, collisions on uneven road surface. The outer joints are responsible for the movement of the wheel discs when changing the direction of movement of the vehicle, that is, when turning. The wheel hub is attached to the SP by means of a flange. This method is considered to be the most reliable and therefore has become widespread. From the inside, attachment with the half-axle pinion is carried out with the help of splines. There are also flangeless axle shafts, which also have splines on the outer side of the shaft, on which the hub or wheel disc flange is attached. This design is used, in particular, in KRAZ/MAZ trucks. The wheel disc is fastened to the shaft flange with nuts, and a ball bearing is pressed onto the end of the axle half. Rubber seals prevent grease from leaking out of the bearing inner cavity. The drive shaft itself is mounted on the bearing by means of a steel lug with a special notch. The lug itself is permanently welded to the bearing housing. The bearing is secured by a circlip which is pressed onto the shaft. Between the clamping ring and the ball bearing there is a spring ring, the purpose of which is to increase the reliability of fixation of the bearing. The bearing is secured in the recess by means of a plate mounted on the flange by means of a bolted connection. The brake shield as well as the oil deflector are also mounted here. To prevent the bearing from knocking, a spring gasket is installed under the outer ring. We have figured out what is the semi-axle of the car, only in general terms, since the specific realization depends on the type of drive shaft. Read also, classification and types of tread patterns on passenger car tires, classification of half axles. As the drive shaft consists of many components, they are all made of different materials. The axle itself is manufactured from special steel grades with additives that ensure the highest strength of the product against all possible loads. Depending on the method of manufacture, The following varieties of half axles are distinguished: solid, when the drive shaft has no removable elements. Most often this design is used on the front axle of the vehicle. It is clear that a solid design is the most durable, but it cannot be called a universal solution. Monoblock axles are also one piece, but they are hollow inside. This reduces strength, but significantly lightens the design. Half axles with a ball bushing are usually installed on vehicles characterized by high cross-country ability. The bushing is precisely the element that provides maximum smoothness of travel and contributes to reducing the noise when operating the axle. Let's consider what forces act on the drive shaft when the car is moving. This is, of course, the force of gravity, which is activated by the vertical component, as well as lateral and tangential loads that arise when turning the car, during skids, when driving on a section of road with a transversely located slope, as a result of the impact of the lateral flow of air, wind gusts. Depending on the design of the external attachment, which determines the level of loading of the shaft by bending moments of different orientation, the following varieties of half axles are distinguished: fully unloaded, semi-unloaded, 3/4 unloaded. In the latter case, the shaft design provides only a support bearing to which the wheel rim/shank is attached. Since this design is unable to absorb bending loads, it is used relatively infrequently. The semi-unloaded drive shaft is usually installed on passenger cars and small trucks that do not experience significant vertically oriented loads. In this case, the place of installation of the bearing is between the SP casing and the axle itself, which, in turn, is attached to the wheel hub. This design leads to the appearance of multidirectional bending moments acting on the SP in the horizontal/vertical planes, as well as in the plane of wheel rotation on the shoulder, the length of which is equal to the tire diameter. Relatively simple design, low weight, low ability to resist loads. Failure of the tire leads to loss of the wheel, which, when traveling at speed, causes loss of controllability and overturning of the vehicle. Fully unloaded drive shafts are the prerogative of buses and heavy trucks. Inside the axle, this design is mounted freely and is secured to the axle beam by two bearings, which are responsible for damping all types of bending moments. The axle is free and is responsible only for the transmission of torque from the power unit to the wheels. Ability to withstand significant loads. Breakage of the axle is not critical. Its replacement is not difficult. When driving a four-wheel drive vehicle, you can even move on using another axle. Disadvantages are the direct opposite of the pluses of semi-unloaded axles: solid weight of the drive shaft, complex design. Causes of malfunction of semi-axles. When moving a motor vehicle, there are many loads that fall on the suspension elements. Part of them is also taken up by the drive shaft. Bending moment, formed under the influence of the Earth's gravitational force, tangential. Bending moment, which occurs during sudden acceleration/deceleration. Lateral impact resulting from skidding of the vehicle, loads experienced by the vehicle when exposed to strong gusts of side wind. The drive shaft is subjected to extreme stresses when driving on roads of frankly poor quality. Although the shaft itself is made of very strong steel and its breakage is extremely rare, this is not the case with other axle assemblies. At the same time, it should be borne in mind that in most cases, the breakdown of the SP leads to a complete, or at best to a partial, loss of controllability of the vehicle, so care for this part of the transmission should be given paramount importance. Read also, what is a sealant for tires and its application? First of all, it is a matter of regularly checking the condition of the bearings. It is they that are considered the weak link in the design of all varieties of half axles. In addition to premature wear of drive shaft parts, there may be mechanical damage resulting from the impact of external objects. Let us list the main symptoms of drive shaft malfunctions: wheel spin occurring at the moment of gear shifting, deterioration or inability to engage some gears, the appearance of precipitation in the system in the form of foam, presence of transmission oil leaks, occurrence of unusual noises localized in the drive area of the vehicle. The vehicle moves away from a straight path and wiggles sideways, vibration coming from the underside of the vehicle. Of course, almost all of these signs are indirect. since they can also indicate other faults that are not related to the drive shaft. Most often, as already mentioned, the normal functioning of the half axles is disturbed due to bearing wear. This malfunction, in turn, causes TM leakage and loss of sealing by the half-axle oil seals. Although transmission oil does not operate under as extreme conditions as engine oil, it is also subjected to extreme heat. Liquefying when heated, it partially loses its lubricating characteristics. The friction force in the shaft nodes increases, which leads to a violation of the integrity of the oil seals. According to statistics, in about 90% of cases of breakage of the axle bearings are the culprits. It should be noted that premature wear of axle parts can be caused by ingress of the smallest abrasive particles. Sometimes bearing failure is caused by defects in locking rings. Another fairly common cause of partial loss of serviceability of the axle half is damage to splines, as well as loosening of bolt fasteners. If you do not keep an eye on the condition of the shaft end devices, at one not-so-wonderful moment they may simply break, which will certainly cause an accident. Usually shafts break in the middle, less often, near the bearing or at the spline itself. For front-wheel drive cars is characterized by such an unpleasantness as the loss of integrity of the protective casing of the ball joint, called anther. This rupture can be associated with various factors: mechanical impact, temperature fluctuations, getting on the surface of chemically active substances, including technical fluids used on the car, as well as simply the venerable age of the dust cover. When tears appear on the anther rubber, moisture, dust, and dirt penetrate inside the shaft, which becomes the cause of its rapid failure. As a result of prolonged operation, the drive shaft mounting points become loose, which causes runout that destroys splines. This is worse than bearing failure, because in such cases the axle will have to be replaced. Often premature failure of SP parts is caused by the owner's actions. Installation of low-quality axle parts during repair operations. That is why it is recommended to purchase only original or recommended by the car manufacturer parts. In this case, you will not have any claims to quality. But any error or inaccuracy in carrying out installation work can cause a rapid breakdown of the elements of the drive shaft. Therefore, it is recommended to carry out diagnostics of half axles every 10 to 15,000 kilometers, preferably with the use of specialized equipment, including measuring stands. Repair of shaft consists in replacement of completely worn or damaged part with a new one. The shaft itself is changed in exceptional cases, for example, in case of geometry loss as a result of a traffic accident or in case of destruction due to corrosion processes. In conclusion, understanding the principle of operation of half axles is crucial for grasping how power is transmitted from the engine to the wheels of a car. These components play a vital role in ensuring smooth and efficient movement, allowing for better handling and stability on the road. By connecting the differential to the wheels, half axles enable the vehicle to navigate turns while accommodating the differences in wheel speed. As we have explored, their design and functionality are essential for the overall performance and safety of any vehicle. Thank you for watching, and we hope this insight into half axles enhances your appreciation of automotive engineering.